So picking up at number 10, we have the cosine is 2/3. We know that's the adjacent over the hypotenuse. So if we make a generic right triangle and we insert one of the acute angles as theta, we know the adjacent is 2 and the hypotenuse is 3. So we can find this third measure here by using the Pythagorean theorem. A squared plus b squared equals c squared. Now let's get a squared by itself by subtracting 4 from both sides. Now take the square root, and a is the square root of 5. Do not change that into a decimal, okay? So now to find the sine of theta, here's theta, we'll do the opposite, which is the square root of 5 over the hypotenuse, which is 3. To find, we already have the cosine. To find the tangent, we'll do the opposite over the adjacent. The opposite is the square root of 5. The adjacent is 2. Now, since sine is the square root of 5 over 3, cosecant will be 3 over the square root of 5. But we know from our radical rules that we can't have a radical in the denominator of a fraction. So what we're going to do is we are going to multiply by the square root of 5 over the square root of 5. That's called rationalizing the denominator. So 3 times the square root of 5 is this, and then the square root of 5 times the square root of 5 is simply 5. Now the secant is the reciprocal function of cosine. So if cosine is 2/3, secant is 3/2. If tangent is the square root of 5 over 2, cotangent is 2 over the square root of 5. And once again, we have to get the radical out of the denominator. So to rationalize it, we'll multiply the square root of 5 over itself. 2 times the square root of 5 is 2 square roots of 5. The square root of 5 times the square root of 5 is 5. Giving us our cotangent, 2 square roots of 5 over 5. Now, looking at our special right triangles with 45, 45, 90, remember the pattern for 45, 45, 90 is x, x, and x square roots of 2. So when it asks us to find the sine of 45 degrees, instead of finding the sine of theta, 45 degrees is now our theta measure. So either angle you can use because the opposite is going to be x and the hypotenuse is x square roots of 2. I can simplify by canceling out those x's and I have 1 over the square root of 2. Now rationalize the denominator and you'll get the square root of 2 over the square root of 2. Okay, now looking at the next one, which is the cosine of 45 degrees. So the cosine is the adjacent over the hypotenuse. Well, that's going to give you the exact same ratio that you had before. So we know that this is the square root of 2 over 2 as well. Now the tangent is opposite over adjacent. So that's going to be x over x, which gives you 1. Now, looking at our unit circle, if you'll look at 45 degrees, we just found the sine, cosine, and tangent of those 3 measures. Now, your sine is always going to be your y value in this ordered pair, and that's exactly what we found as our answer. Okay, the sine of 45 degrees is the square root of 2 over 2. The cosine is going to be your x value. That's going to be the square root of 2 over 2 as well. Then your tangent is your y value over your x value. A number over itself always gives you 1. Now let's look at the pattern for 30, 60, 90. So remember, across from 30 is your x, across from 60 is x square roots of 3, and across from 90 is 2x. So let's deal with 30. First of all, we're going to find the sine of 30 degrees. That's going to be the opposite over the hypotenuse. So we end up with 1/2. Now the cosine is going to be the adjacent over the hypotenuse, and that gives us the square root of 3 over 2. Tangent is opposite over adjacent. Oops, you can't see, can you? and cancel those out. And we have 1 over the square root of 3. Rationalize the denominator to get the square root of 3 over 3. Now look at 30 degrees right here on your unit circle. We have the square root of 3 over 2 and 1/2 as our ordered pair. Your sine is always going to be your y value, which is 1/2. Look at what we got when we solved. Your cosine is always your x value, the square root of 3 over 2. Look at what we got when we solved. And then your tangent is y over x, which will be 1/2 over the square root of 3 over 2. That's a copy, change, flip situation right there. And you'll get the square root of 3 over 3. Now let's look at the sine and cosine and tangent of your 60 degrees, which is going to be this one right here. So opposite for sine is going to be x square roots of 3 over your hypotenuse, which is 2x. That's going to give you the square root of 3 over 2. Cosine is going to be adjacent, which is x, over your hypotenuse. That's 1/2. And then tangent is opposite over adjacent. That's the square root of 3. So, once again, let's go look at our unit circle. Okay, right here at 60 degrees, we have 1/2 and the square root of 3 over 2. So we know the square root of 3 over 2, our y, should be our cosine. They match perfectly. We know that our x, 1/2, is our cosine, so 1/2 and 1/2. And then tangent is y over x, or the square root of 3 over 2 over 1/2, which gives us the square root of 3. So everything works out beautifully for these. Sine is y, cosine is x, tangent is y over x, and it comes from these ordered pairs right here in the unit circle.